students, very good morning. How are you all?
Good morning, madam.
All right. So, before proceeding with today's session, we'll just do a quick recap of whatever we have discussed in the previous 1 or 2 sessions. Okay. Let's start with specific heat. We discussed about specific heat, and the formula for specific heat is equals to Q by M delta T. Right? Q is the heat energy, M is mass, and delta T means change in the temperature. Right? And what else we have discussed? We discussed about the principle of method of mixtures. What does it state? When two or more objects are in thermal contact, they attain thermal equilibrium. How do they do that? The heat is transferred from the hot bodies to the cold bodies. In other words, net heat lost by the hot bodies equals net heat gained by the cold bodies. Right? Using this principle, we have found out a formula to determine the temperature of a mixture when two or more samples of different temperatures and different masses are mixed. What is that formula? T equals M1T1 plus M2T2 by M1 plus M2. Right? Wherein this formula is for when we have two samples with different masses and different temperatures. When they are mixed together, this would be the resultant temperature of the mixture. Alright. And what else we have discussed? We discussed how to determine the specific heat of a solid. We have done this with the help of a lab experiment wherein we have used calorimeter and lead shots. Right? So we have learned about determination of specific heat of a solid in laboratory. Alright, that is done. And after that, what did we talk about? We have talked about the process of evaporation. Correct? What do we remember about evaporation? So this is a process wherein the molecules from the surface of the liquid escape. So the escaping of the molecules from the surface of the liquid at any temperature is called as evaporation. And we have also learned that evaporation is a surface phenomenon and it is a cooling process. Today in this session, let's look a little deeper into evaporation and understand how this works. Right? Now, the rate at which any liquid evaporates depends on certain factors. Okay, depending on the factors like the surface area, humidity, and the wind speed. Depending on these factors, the rate of evaporation varies. Let's see how this will affect the rate of evaporation. First factor is surface area. Second one is humidity. And third one is wind speed. So now we will discuss the effects of these three on evaporation. Okay, let's begin with surface area. Now, we have already established this fact that evaporation is a surface phenomenon. Why? Because the molecules which are present at the surface of the liquid escape when they gain enough energy from the collisions of the molecules. Right? So evaporation occurs from the surface of the liquid. That's what we have learned. Right? Now, if the surface area is more for any liquid, then that means more number of molecules are present at the surface, right? So when more number of molecules are present at the surface, there is more scope for these molecules to escape. So more surface area will provide us more room or more scope for evaporation. So less surface area means then less number of molecules are present on the surface. So rate of evaporation reduces there. So there is a direct correlation between surface area and evaporation, right? As the surface area increases, the rate of evaporation also increases, because more surface area provides us with more scope for the molecules to escape from the surface, because more number of molecules are present at the surface. Okay, moving on. Humidity. What do we mean by humidity? Any ideas?
No, madam.
Okay. So the atmosphere, the air around us, it always has water vapor molecules, water vapor particles present in it. See, these vapor molecules could be from the nearby water bodies like rivers or lakes or ponds or wells, right? This can be from the rain. Yeah, this could be from the household chores that we do with the help of water, right? We keep washing our clothes, our vehicles. So yeah, from these water sources, water bodies, some or the other sort of amount of water vapor would always be present in the air around us. So this amount of water vapor present in the atmosphere is called as humidity. The amount of water vapor present in the air or atmosphere is called as humidity. So if more water vapor is present in the atmosphere, then we say that it is very humid. So less humid means less amount of water vapor present. Now, at any given temperature or pressure, the air can hold only a definite amount or certain amount of water vapor. So exceeding this, the air cannot hold any excess amounts of water vapor. So at any given condition, there is a limit to how much of water vapor or how much of humid the climate can be. So beyond that, the air cannot hold water vapor. So when the climate is humid or when the humidity is high, the rate of evaporation is low, because air already contains vapor particles in it. So there is no room for these escaping molecules. So they would be sent back, they would be returning back when they collide with the water vapor particles in the air, they would return back to the surface. So the relation between evaporation and humidity is as such. More humidity means rate of evaporation is less. Less humidity means rate of evaporation is more. Any questions at this point?
No, madam.
Is it clear?
Clear.
Okay. Okay, moving on. Wind speed. We have already seen how this works in our previous session. Yeah, we have discussed how when we want our floor to dry faster after mopping it, we turn the fans on, we switch our fans on, right? And on a windy day, our clothes would be getting dried up faster. So why is that happening? Again, we'll have to go back to the concept of evaporation. The surface molecules escape from the surface of the liquid. Now when there is wind, when there is a wind flowing, what happens? This wind sweeps away these escaping molecules away from the surface. So these escaping molecules are blown away from the surface. That means there are very less chances of these escaping molecules to return back when there is wind, because they are being constantly swept away, right? And also when there is wind, this wind will also sweep away the vapor particles present in the air, right? So the vapor particles are also swept away from the surface of the liquid. So this will provide more room for the liquid to evaporate. And hence, when there is more wind or when the wind speed is higher, then the rate of evaporation is also higher. Clear? So these are the effects of surface area, humidity and wind speed on evaporation. Any questions?
No.
So having said that, let's quickly redefine evaporation in another way and then we'll proceed to the next topic. So now evaporation can be defined as the change of phase from liquid to gas which occurs at the surface is called evaporation. Clear? This is a surface phenomenon. So this phase change from liquid to gas is occurring at the surface and hence it is a surface phenomenon. That is your evaporation. Clear? Now we'll go ahead and discuss one more interesting process, which is condensation. So to understand condensation, let's look at few real life observations that we make very often, right? So let's say we fill a glass with cold water, or we take out a water bottle from refrigerator and we put it on a table. What happens after a while? We see tiny droplets of water on the outer surface of the glass and water bottle, correct? What do you think is happening there? Let's say I take out a glass and I fill it with cold water. Okay, so after a while I see water droplets on the outer surface. Now understand this. When I pour cold water inside the glass, the temperature of this water would be very much less, right, compared to the temperature of the surrounding air. So the surrounding air is hotter than the temperature of the water inside the glass. Now we know that air contains some water vapor. Yes. Now these vapor particles present in the air, they collide with the glass. So when they collide with the glass, what happens? These vapor particles are at a higher temperature and the glass is at lower temperature. That means heat energy is transferred from these particles to the surface of the glass. Energy is transferred, right? And this transfer of heat energy will decrease the kinetic energy in these water particles, water vapor particles, right? What happens as a result? The temperature of the vapor particles in the air falls. Once the temperature falls, the water which is in the gaseous phase will change into water droplets. So these water droplets will settle on the surface of the glass because temperature was decreased. So linear kinetic energy, the kinetic energy of these water vapor particles is reduced and they change into liquid state and they settle on the surface of this water glass or water bottle or the colder surface, whatever it is. Now in turn, the energy from this vapor particles is being transferred to the glass, and again from the glass the energy is transferred to the water inside, right? Now what happens? This transfer of energy will increase the kinetic energy of the water inside this glass. Now kinetic energy is increased, that means temperature is increased, correct? So what is happening then? The temperature of the water inside the glass, this temperature starts to raise. So after a while what happens? The water will not be as cold as before. The water will become warmer and hence the condensation is a warming process. Okay, understand what is happening here? So let's look at this again. Condensation. Now what is happening? The vapor particles in the surrounding air are warmer or at a higher temperature when compared to the cold water or the cold objects present. Now, when these vapor particles collide with the glass or the bottle, this heat energy is transferred from hotter bodies to colder bodies. This transfer of heat energy will result in the decrease in the temperature. So once the temperature of these water vapor particles is reduced, the kinetic energy is also reduced. Now this reduction in the energies and this reduction in temperature will convert vapor particles from gaseous phase to liquid phase, and they turn into water droplets. These water droplets settle on the surface of the glass. Now this energy will be in turn transferred or flown to the cold water inside. This transfer of energy will raise the temperature of the cold water inside. So the water gets warmer, and hence condensation is a warming process. So to define it, condensation is the phase change of gas to liquid is called as condensation, and condensation is a warming process. Any questions?
No, ma'am.
Is this clear?
Clear.
Okay. We hear these words very often, right? Dew and fog. What do you think these are? These are formed as a result of our condensation. Okay, let's see how it works. So during our winter nights, what happens during night times in the winter? The temperature of the air, surrounding air and the atmosphere falls down rapidly, right? So atmosphere gets cooled down very rapidly. Now, as a result of this, the objects like our window panes or the car shields, the vehicles outside, the grass, the plants, leaves, etc. So the temperature of all these objects also would be reduced. Correct? So the temperature would be reduced and all these objects are at colder temperatures, right? When compared to the water vapor particles present in the air. Now, the same thing happens. Once the water vapor particles present in the atmosphere, present in the air, once they collide with these surfaces which are much colder, the heat is transferred. And just like how we have seen previously, the vapor particles are turned into water droplets, and these water droplets settle on our car windshields, on our vehicles placed outside, on the grass, leaves, flowers, etc. So that is what we call as dew. Dew is the water droplets. Dew means the water droplets formed on the surfaces due to fall of the temperature of those surfaces. Any questions?
No, madam.
Okay. Then what is fog? So when temperature falls down even to colder temperatures, right? Once the temperature becomes even colder, what happens? See, the water vapor particles in the air will immediately turn into water droplets. They lose their energy due to very, very cold surroundings, and the temperature falls and they turn into water droplets. So these water droplets will now settle down on the air particles. So this could be dust particles in the air or smoke or whatever it is. So these water droplets turn into these water vapor particles turn into water droplets, and they settle down on the air particles, dust particles or smoke particles, etc. So a thick mist is formed. See, these water droplets will be floating in the air and a thick mist would be formed. So this thick mist is our fog. And this, what does it do? It will restrict our visibility. It becomes quite harder to see when there is fog in the atmosphere. So that is how dew and fog are formed. These are the results of the condensation. Alright, any questions?
No, madam.
So far in this session, we have studied about evaporation, we have defined evaporation, and we have studied how surface area, humidity, and wind speed affect rate of evaporation, right? And also we have learned about condensation, right? Condensation is phase change from gas to liquid, correct? And condensation is a warming process. Why? Energy is being supplied to the colder surfaces or to the colder objects. Energy from the vapor particles is being supplied, and hence this is a warming process. And also we have discussed about dew and fog. Any questions?
No, madam.
In the coming sessions, we'll be discussing about few more interesting phenomena like melting, boiling, freezing, etc. Let's come back in the next session to find out more. Thank you.